Hello students, welcome to another video session on circular motion. So it is another practice session. This is an interesting question about a train that is trying to negotiate a curve. Then I'm given a few details about this. So the key thing is to have a clear picture of all the forces acting on this. So try to read the question, understand the question, then try to visualize what is happening and then what you're trying to find. Okay, so if we just extract what the question is giving us. So in form of a diagram, before we get the values, in form of a diagram, what we have is you have, if I was to draw the two rails, not really the distances, but their positions. So you have one rail at some point, and then the other one somewhere there. So if you had the horizontal, now what we want to find is how high the other track must be elevated so that there's not going to be any lateral forces on the tracks. Okay. Now, of course, this angle is going to be theta. We're going to use theta for this angle. So the first step is just to have a clear picture of all the forces that are acting on the train. So if this is the central point of the train, if I use that part, so we just want to have a clear picture of all the forces. Then you can easily see how we can work it out. So of course, if we pick one central point, so the first step is we can show the direction of the weight. So the weight will go straight down. That's the weight of the train. That is going to be mg. Now next thing, we want to also show where the normal force is. So the normal force is going to be perpendicular to the plane. So it's going to be somewhere there. Okay, so this is our normal force to the surface. Okay. Now next up, I'm just going to extend this force. Okay. Now, one thing that you guys should observe is if this angle is theta, then the angle here is also theta. Now, if the angle there is theta, it means that this angle here is also theta. Now, if you look at where the center is, the center of rotation is somewhere in this direction. So somewhere here, this is where you have the center. Now, the centripetal force in this case is going to be any force that is going in that direction. And you guys should be able to see that this is going to have, the force normal is going to have a component that will act in that direction. So let's call it the x component. And then somewhere here, you're also going to have a y component. So let's call it fy. Now, if we're just going to show the mathematics of what happens here, if we get that triangle, which is way on top there. So what we have is the centripetal force that is going in this direction. And then you have the y component that is going up. And then you have, that is our force normal. Okay. Now we're saying in the x-axis, we have that x component of our force. And this is the one that gives us our centripetal force. So I'm going to write it like that. But then when we look at this, we want to see the expression of the angle in terms of the normal and the angle. So what we see is these are related by sine. So we see that sine the angle theta is equals to the force in x over the force normal. And then eventually the force in x is equals to the force normal multiplying sine theta. So if I bring this here, we have the force normal multiplying sine theta. This is equals to centripetal force. But then recall that the centripetal force is equals to mvt squared over r. So when we substitute, we now have the force normal sine theta is equals to mvt squared over the radius. Okay. Now, if we go back to our question and we just want to see what velocity we're given. So the velocity we're given is a tangential velocity. So we can leave our velocity in terms of its tangential form. Okay. So this then becomes our equation 1. Now, next up, we go to the y-axis. What is happening in the y-axis? If we come back to our diagram, so remember when I'm saying the y-axis, the x-axis, I'm talking about in this frame. So as in the horizontal being the x-axis and the vertical being the y-axis. So in terms of this dimension, what you notice is we have mg going down, and then going up, we have fy. So if we follow Newton's second law there, the sum of forces in the y, what you're going to have is fy going up minus mg going down. This is equals to 0. So implying that fy is equals to mg. Now, if we go back to our diagram here, now fy is this one. So it's related to the side by cos. So you see that cos theta is equals to the adjacent, which is fy over the force normal, the hypotenuse. So from here, we see that fy is equals to force normal multiplying sine theta. So when you substitute here, we now have force normal sine theta is equals to mg. So this becomes our second equation. Now here again, we're going to use, sorry. So here the two sides, the y component and the angle are related by cos. So this is an adjacent side. Yeah, okay, I think I did that. It's only here where I wrote it wrongly. So this is cos theta. So I hope you guys are able to see through that. So if we correct this, this is force normal cos theta. So from this stage, you can work out equation 1 and equation 2 in whichever way that you prefer. I feel for me the easiest is I can divide. So I can divide equation 1 by equation 2. So the left hand side is going to be Fn sine theta divided by the left hand side of equation 2, which is Fn cos theta. The right hand side from equation 1, we're going to have m vt squared over r divided by the right hand side of equation 2, which is mg. So from here, the force normal will cancel out. Sine theta over cos theta is tan theta. So this becomes tan theta is equal to, so on the right hand side, what you're going to have the mass, and the mass will cancel out. So you're going to have vt squared over r multiplying 1 over g. So this just becomes vt squared over rg. So we want to find the angle. So this would then imply that theta is equals to tan inverse of vt squared over rg. Okay, so this is how far we've gone. Now the next step, so just get our equation. Theta is equals to tan inverse of vt squared over rg. Now the next step is you want to get everything that the question gives us. So the question gives us the tangential velocity vt, and it is given to us in kilometers per hour. So we want to convert that kilometers per hour into meters per second. So when you do that, we have 50 kilometers per hour. And if we convert this, so to convert this, we're just going to multiply this. So let's write it better. This is kilometers, not kg. Kilometers per hour. So we're going to multiply this. First, we'll convert the kilometers to meters. So I'm going to have the kilometer in the numerator, in the denominator. And then this is multiplying 1000 meters. And I'm going to convert the time to seconds. So I'm going to have the 1 hour in the numerator, now multiplied by 3600 seconds. So if you do this, you should be able to get 13.9. This is going to be meters per second. So once you've got this, the other thing that the question gives us is the radius. R is equals to 500 meters. Then we also have the distance between the two rails, which is 1.5 meters. And then what you're trying to find is h. Okay. So from our formula, first of all, we have theta is equals to tan inverse of Vt squared over Rg. So we have everything we need here. So this is tan inverse. V, we found 13.9 squared over. Okay, so this is over R, the radius is 500. Then multiplying G, which is 9.8. So if you work this one out, you can try it very quickly. You should be able to find 2.26 degrees. Okay, so once you found the angle, what it means is the elevation between the horizontal and the track, this angle here, this should be 2.26 degrees. So now to find our h, this now becomes very, very easy. Since we already know what this, I call it, I label it d, we know to say this must be 1.5 meters. So now I want to find this h. So you can see that the relationship here is sine. So you can say sine 2.26 degrees is equals to opposite, which is h over 1.5. So from here, cross multiply, you see that h is equals to 1.5 multiplying multiplying sine 2.26 degrees. So if you work this one out, you should be able to see that your answer comes out as 0.0592 in meters. When you convert this to centimeters, multiply this by 100, this becomes 5.92 centimeters, or then approximate this to just 6 centimeters. Okay, so that's how you work out this question. It was a little bit straightforward, really. Okay, so I can quickly work out the second question for this video. So which is based on a satellite rotating around the Earth. So this is we're going to use a concept here from Newton's law, which is just basically Newton's law of universal gravitation. So let's quickly just state it. So Newton's law of universal gravitation states that if you have two objects, two particles, they will exert an attractional force, or there's going to be an attractional force between them. The attractional force will be directly proportional to the product of the masses, but inversely proportional to the square of the distance. So what are we saying? If there is a distance between the two particles, and the distance we're calling it, let's say, r, so Newton's law of universal gravitation states that there's going to be a force between the two objects, which is directly proportional to the product of the masses, but inversely proportional to the separational distance, the square of the separational distance. So if you change the proportionality to an equal sign, you now have equal to g m1 m2 over r squared. Now in this case, g is the proportionality constant. So now if we apply this to our question, so what we have is you have the Earth somewhere here, and then you have a satellite which is rotating around the Earth. You have a satellite at some distance. Now, if you're standing on Earth, what we are now saying is, following the law of universal gravitation, there's going to be an attractional force that is going to act, pulling the satellite towards the Earth. This is given by the law of universal gravitation. But since the satellite is orbiting the Earth, it's going around the Earth. from circular motion, what we're now saying is, it means that this same attraction of force between the satellite and the Earth, this force must be the one that gives us the centripetal force, since it's a force that is going towards the center. So what this means is, first of all, we know to say this force, the attractional force, is now equal to the centripetal force F. So from the law of universal gravitation, what we have is G in M1, M2 over R squared. But then from centripetal force, what we know is M Vt squared over R. Now let's let M1 be equal to the mass of the Earth, and then M2 be the mass of the satellite. So in this case, it means that since the satellite is the one rotating, this must be M2, since it's rotating, it's the one that is experiencing the centripetal force. So in this case, from the equation, you see that M2 cancels out from both sides. And then apart from this, one R cancels out in the denominator here. And the other side, it goes all the way. So the equation now remains M1 over R is equals to Vt squared. So here now, we want to find the mass of the Earth. So this remains M1 is equals to R Vt squared over G. Okay. Right. So in this case, so this is the equation that we're going to use to find our answer. This is the key equation we're going to use. Okay. Now, what are we given in this question? So let's quickly get the question and see the quantities that we need to use. Okay. So from the question, we're given the angular velocity. So we're given G. G is 6.67 by 10 to the power negative 11. And then apart from that, we're given the radius, R. This is 6,500 kilometers. But of course, this is just 6,500,000, since we have to use it in meters. Then the next thing that we're given is the angular velocity. So the question says the satellite orbits the Earth in about 87 minutes. What that means is to make a full rotation. So it's going to make one full rotation in 87 minutes. So you have one revolution in 87 minutes. So you can actually write this, and if you just want to interpret it completely. So it's one revolution in 87 minutes. Now we need to convert this to radians per second. So now how do we do that? So let's just do it down here. So we want to convert one revolution over the 87 minutes into revs per second, into radians per second. So to do this, first we're going to convert the revolutions to radians. So we know to say in one rev, we have 2 pi rads. This will take care of the revolution. Then the next thing we want to convert the minutes to seconds. So we know to say in 1 minute, we have 60 seconds. So notice how I keep switching the units. If I want to eliminate something in the denominator, then I'll put it in the numerator. This will ensure that this cancels with this. And then here I was eliminating something in the numerator, I used it in the denominator so these cancel out. When you do this, you're going to find the angular velocity as 0.0012. So you can take it like this, or you can use it in full. And then now to work out our mass, what we're going to do now is our mass, M1, which is the mass of the Earth, it's going to be equivalent to, that's going to be the radius. The radius is 6,500,000. Multiply this by VT squared. Now remember what VT is. To get VT, since this is our omega, so VT is equivalent to R omega. So you basically just have to multiply our omega. We have to multiply our omega by the radius. So let's just do that. So VT, the tangential velocity, is equals to R omega. So we found what our omega is. So our omega is 0.0012. Our radius is 6,500,000. Multiply this by 0.0012. So work out this. You're going to get, you can use the full value and then just round off at the end. So this is going to give you 7,823.89. So this is a tangential velocity, so the units are going to be the meters per second. Yeah, so this is going to be the meters per second. So once you've done this, then you can substitute in our formula. Let's do it properly on the next page. So when you substitute the VT in our formula, remember our formula, it's the mass of the Earth is equals to RVT squared over the G. So this becomes the radius, 6,500,000, multiplying, and then we've just found what our VT is. So that's 7,824.89 squared divided by our G. So the question gave us a G, and that was 6.67 by 10 to the power negative 11. So work this one out. It will give you 5.97 by 10 to the power 24 kgs. Okay. All right. So those are just a few basic questions, really. They're not very complicated. I hope you guys were able to follow through. Yeah. So I hope you found this video very helpful. If you did, drop a like. And if you don't want to miss any of my future videos, just subscribe to the channel, and then you can just click on that notification bell so that you are alerted every time when I upload a new video. So we're going to continue still practicing. I think I'm going to make 1 or 2 more videos before we move to look at what inertia is, the moment of inertia. All right, next time. See you next time.